So we're going to be learning, well, when I say learning, actually it should be refreshing for most of these, some angle relationships, angle facts that you should have learned in 8th grade. Now, it's been a while since then, so I'm going to treat it as though this is all new for you, even though a lot of it, you'll be like, okay, I remember learning about that in the past. We're going to have, I can't remember the total, let's say somewhere around a dozen angle relationships that you need to know. And I'm not going to give you all 12 of them right away, or however many it is. We're just going to look at the first batch of them today. So I'm going to give you guys 5 angle relationships, and we're going to practice with those. And then we'll throw in another batch that are all kind of related to each other. And then there will be a third round of this. And so over the course of the next week and a half or so, we're going to be introducing all these angle relationships that we're going to be using now and moving forward for a lot of the content. Not everything that we do in class depends on these, but a lot of what we do. So we're going to start off with what we call vertical angles. And when I say that, hopefully that's ringing a bell, and you guys are like, oh yeah, I've heard of vertical angles before. But again, even if you haven't, or it's been so long that you've completely forgotten, it's okay. That's why we're going over it again. So vertical angles. And I'm going to go ahead and put a star beside this one. This one's going to be a really important angle relationship that comes up quite a bit. Okay, so the diagram for this, I will just show an intersection. And on the left side, I'll call this angle A. On the right side, I'll call this angle B. I could have done the top and the bottom, but I went ahead with the left and the right just to get the point across that when we talk about vertical angles, it doesn't have anything to do with being straight up and down like we think of vertical. It's just another word for being opposite of each other. So angle A is opposite of angle B, and in our description we'll make note of that as well. So what we can say here is that angle A is congruent to angle B, and that's one way of writing this. Anytime you have these opposite angles at an intersection, they will always be congruent to each other. There is another way we could write this, which is just a subtle difference, but I think it's an important one that we are aware of. We could say that the measure of angle A equals the measure of angle B. And the difference between writing it these two different ways, when we say angle A is congruent to angle B, we're not at all concerned about what the actual angle measure is, how many degrees it is. That's not anything that we're concerned about. But when we say the measure of angle A equals the measure of angle B, we're saying that the two angle measure numbers are equal. The numbers themselves are equal to each other. So in this case, I would guess angle A is about 65 degrees. It doesn't really matter. We could call it anything we wanted. Let's say it's about 65 degrees. That means the actual number measure of angle B is going to be 65 also. So that second one, we're talking about the numbers, and that's going to be a lot more useful for a lot of the stuff that we're doing. So we're going to be referring from here forward for the measure of angles, but it'll circle back around. We'll talk about congruency more when we get to our next unit. Okay, so hopefully it's just like a minor thing and it's pretty clear. I'm not a big stickler for that, so if you accidentally write it the wrong way, technically, then as long as I get the idea, I'm okay with it. So measure of angle A equals the measure of angle B. I gave you guys those highlighters because we're going to be color coding along the way. Anytime we have an angle relationship where the two angles are equal to each other, we're going to highlight that in yellow. So I'm going to go ahead and have you guys highlight, just like I am up on the screen. So the measure of angle A equals the measure of angle B, and vertical angles highlighted as well. Okay, so let's go ahead and write down our description on that as well. The description is really just going to be, if you look at the diagram and you want to make sure you know what's going on, a lot of the time the diagram will be good enough, but the description might help you just to clarify that a little more. So angles opposite each other at an intersection of lines or segments So, angles that are opposite each other at an intersection of lines or segments are supplementary, or sorry, that's not true, are equal in angle measure. Okay, now we will also be referring to these angle rules quite a bit, and you're not always going to want to write out fully vertical angles, so that's why that abbreviations is there. And the abbreviation for this, we'll just abbreviate that to vert for vertical, and then the angles symbol.
How many of these do we have to do?
We're doing 5 of these today. Okay, and the next one is going to be what's called the angle addition postulate. And for our purposes, just think of a postulate as kind of a rule. It's similar to a theorem, but it's kind of a strange word for it. Okay, so the diagram we're going to draw here, we've got a couple of angles. This is going to fill up the rest of my page here, but you can make it as small as you want to try and squeeze more in. So we've got angle addition postulate. I've got an angle right here. I've got an angle right here. And then I'm going to draw another larger one. And I'm going to go ahead and label all these. So I'm going to have A, B, C, and D. Right there. And it's good to get some practice writing out these angles with the angle notation. So we'll go ahead and write this down, and I'm going to see if you guys can kind of figure out what this is telling us. This angle addition postulate is a straightforward idea, but it is one that we don't use very often. So when it does come back up, I hope it's simple enough that it's pretty obvious for you. So the measure of angle ADB plus the measure of angle BDC is going to be equal to the measure of angle ADC. So just looking at that equation and the diagram, can anyone kind of put into plain English what's going on here?
The angle of both are added up equally to like the whole line.
That's it, basically. Yeah, we've got 2 smaller angles, and when we add those up together, it's going to equal the angle of the larger one. All right, so we'll write that in kind of a different way here, but the same basic idea. And we'll do the highlighting in a second. But we've got 2, and it could be more than 2, so I'll put 2 or more angles, or adjacent angles, I'll add that in. I'll come back to that term adjacent. Add up to the measure of the larger angle. And the abbreviation, I'll go ahead and add it on there. It's just going to be AAP. Okay, so just to clarify a little bit here, it says 2 or more adjacent angles. I added that word adjacent in. Adjacent means, well, we know adjacent means right next to things, right? So the building adjacent to this one, stuff like that. So these 2 angles are adjacent because they share a vertex and they share one of the segments, and they're right next to each other. So that's the easiest way to think about it. 2 angles that are right next to each other. So 2 or more adjacent angles will add up to the larger angle. So it's a pretty straightforward idea. We use yellow when we're talking about an angle relationship where the 2 angles are equal. That's not the case right here. What we've got are 2 angles that add up to equal a third. This is going to be one of our kind of random angle relationships. And this kind of fits, we're going to highlight this one blue, because this is going to basically be an angle relationship that doesn't fit one of our other 2 categories. And we'll see what that third category is here in just a second. Okay, and again, I hope the color coding helps, so you can quickly look. Anytime you see yellow, you automatically know these 2 angles are congruent. And you can set up your equation knowing exactly what the angle relationship is. Anytime you see blue, you know it's going to be something a little different. You might have to look at that one and review. Though we'll do it enough. Hopefully some of these you kind of remember. Okay, we're going to jump ahead and we're going to look at the last 3 angle relationships for the day. Was anyone still trying to write anything?
What does pink mean?
That's the last one we're going to come to. And we'll look at our next one. We're going to add a star next to this one, and this is linear pairs. Okay, the diagram for this, pretty simple. We're going to have a line, and we're going to have a line coming off of it. I guess these are 2 segments. And I've got angle A and angle B. Now notice that the name says everything. It's linear pairs. The linear part of it is that these are on a line. The pair is that we have a pair of angles. So linear pairs. And our basic angle relationship here is that the measure of angle A plus the measure of angle B, what are those going to add up to? 180 degrees. All right, so if that 180 came out of nowhere for some people, and again, most people I hope don't need to see this, but just in case there's any confusion, just remember that whenever you're coming up with angles, if you start off with your ray going one direction, this is not part of the diagram. You don't need to draw what I'm doing down here. But you can have your ray going off any number of directions. So this angle right here is going to be measured up from here over. We start at 0 degrees right there, and it measures up whatever that is. Now if you ended up going the entire way and had this line go all the way this direction that way, well, this entire angle coming around is 180 degrees. Which is why anytime we have a line, we can just consider that a 180 degree angle. Okay? If there's still confusion on that, let me know. But again, it should be stuff that you guys are more or less familiar with. Okay. So the description here is that, let me make sure I'm giving you the right description on this one. All right. Two adjacent angles that form a line are supplementary. And I threw in the abbreviation right there, it's just LP. Okay, so there's a couple things here. We've got angles that add up to 180 degrees. Anytime we have an angle relationship where things add up to 180 degrees, that's when we're going to use our pink highlighter. And it has to be 180 degrees, not any other angle measure. So almost all of the angle relationships that we are going to be exploring are ones where the angles add up to 180 or the angles are equal to each other, which is why those are the two main categories. Anything that doesn't fall in those two categories, we're just going to highlight in blue. Okay, we also threw out this term supplementary, which is a term that hopefully you guys have come across before. Does anyone remember what supplementary means? Okay, supplementary is two angles that add up to 180 degrees. And it's always two angles that add up to 180, not like 3, 4, or 5 angles. So I just want to clarify what this word means. Okay, and that basically covers it for your linear pairs. But these show up quite a bit, and I can maybe show you guys a diagram to figure out why linear pairs show up so often. Vertical angles show up all the time, so do linear pairs. Because if I start taking, and again, this is a diagram you don't need to draw. I'm just going to draw it in the blank space down below. If I start drawing random lines, alright, so I've made this quite complex down here. There's a bunch of intersecting lines, but so many places that we look at, you can see, and I'll show this in a different color, I've got a linear pair right there that I just marked. I've got vertical angles right here. I've got a linear pair right here. And I've got vertical angles that show up right here. So linear pairs and vertical angles are always going to be in diagrams. And we don't always need to use them, but they are always present. And we need to make sure that we're aware of them and we can look to see, is this going to be an angle relationship that matters to us? Okay, I'm going to get rid of all that because it's not important to the next part. Let's look at our fourth angle relationship. And this is one that's very closely related to linear pairs. This is called angles on a line. Very descriptive name because what we have here are angles on a line. So I'll just show angle A, angle B, angle C, and angle D. This is not as common as linear pairs because we just saw linear pairs shows up in every single diagram, whether we need to use it or not. Angles on a line will not always show up, and this is whenever we have more than two angles. So I'm just going to show this real quick. I've got measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D. And I could have done this in different color. I could have added more or less angles. It could have been 3, 4, 5. I just went with 4. It's easy enough to do. So these are all going to add up to what?
Measure angle A.
Well, it's just going to be, in this case, because they're all angles on a line, it's still 180 degrees.
Oh.
And for our purposes, we don't care if it's 2, 3, 4, or 5 angles that add up to 180. Anytime we have an angle relationship where things add up to 180, we're going to highlight that in pink. I'm not putting a star by this one because it's not as common. Okay, now we're going to throw out some terms here, make sure everyone's on the same page, but the description of this is that consecutive adjacent angles on a line sum to 180 degrees. And our abbreviation for this is just going to be angles with the angle symbol, angles on a line. So it's not much of an abbreviation, but I do want you to write it out that way. That way it's always clear what it is you're referring to. So just to clarify on the notation in here, it says consecutive, the terminology, consecutive adjacent angles on a line. So we already talked about adjacent angles, or those that are right next to the other. Consecutive means we have a bunch of them all in a row, one after the other. So in this case, we have 4 of them that are right in a row, and they all add up to 180 degrees because they're all along a line. All right, last one. Are all these angle relationships pretty simple so far? Okay, hopefully so. All right, the last one is angles at a point. Okay, so angles at a point, the diagram is going to look something like this. Again, I'm showing this with 3 angles, but I could have made this with 4, 5, 6.
Is this our last one?
Yeah, it's the last one for the day. And the basic idea with this is that the measure of angle A plus the measure of angle B plus the measure of angle C equals, well, what is this all going to equal? 360. Now we're going the entire way around a circle. If I start here where A and C meet, and I go all the way around to the end of angle C, then that's 360 full degrees, a full rotation around. And the name itself will hopefully make sense because it's angles at a point. This point right here in the very middle, we didn't name it, but the point that we're going around is the point, so we have 360 degrees going around that particular point. All right, and the description on this, well, actually before we do that, what color do you think we're going to highlight this one? Blue, there you go. It's adding up to 360. It's the only one we have that does that. So it's just kind of an oddball, but it's not too hard to remember that, I hope. And our description is that angles at a point sum to 360 degrees. And our abbreviation for this is just going to be angles at a point, and I can abbreviate point a little bit. And those are the first 5 angle rules that you need to know.